So we've now got two tools in our toolkit. We can collect like terms and we can multiply out the brackets. The next thing that we are going to look at is something called a binomial product. So binomial means two. So I've got two pronumerals sitting in here. So that's my binomial term, and a binomial product is a multiplication of two such things. So something of the form A plus B times C plus D is what we're going to call a binomial product. Okay, that's our fancy terminology, if you like. Quite often in algebraic expressions we need to multiply, or we need to be able to rearrange a binomial product. And there's nothing new here, because to expand a binomial product we just use our distributive law, but we do it twice instead of once. So let me do it. Sitting in here, I want A plus B times C plus D. Now, for any choice of A and B, A and plus B is just a number. Right? I don't know what number, but it's a number. And if it's just a number, then I can come back to here and say, look, it's just a number times C plus D. So I can apply my distributive law, keeping A plus B as my number. So that will become, here, according to my distributive law, A plus B times C plus A plus B times D. That's exactly this one here, except instead of A there I had A plus B, and then I had C plus D sitting in there. So that's my first step. Now in here, we know it doesn't make any difference whether I multiply A plus B by C or C by A plus B. I can reverse that order, so I will. I'll say that's C times A plus B, and likewise I'm going to write that as D times A plus B. Doesn't matter which order. Now, I've said I've used the distributive law, so I actually used it 3 times, because this looks like a distributive law and that looks like a distributive law. And so in here I can say this is C times A plus C times B, and here I can say this is D times A plus D times B. So I should say 3 times in there. Thrice is what I should have said, isn't it, rather than... Now, in here, C times A is the same as A times C, so I guess I could write that as AC. When I'm adding things up, it doesn't matter what order I'm going to do this. I'm going to write that one in front of that one, and I'll go AD plus BC, which is that one, and lastly plus BD in there. And that way, that looks like that. And so there is my binomial product in there. So let's highlight that and say that's important. Once you realise that that's just the same as using the distributive law, we'd like to be able to do that expansion relatively quickly. And so rather than going through this all the time, we can just remember how to do it. And so in here, I think what students are taught at school is something that the acronym FOIL. So the FOIL, we use the mnemonic FOIL. And this stands for first, outside, inside, and last. FOIL. And what it says is multiply the first term, so if I can indicate them there, the first term in each binomial term, so that would be AC. Now multiply the outside ones, so that's A times D. Now the inside ones, which are B and C, so plus BC. And lastly do the last ones, which in this case is B and D. plus B and D. And so there's my FOIL mnemonic for remembering how to do a binomial product. I don't care what you do. You can actually multiply it out like this, or you can remember the FOIL algorithm. I don't care. As long as you can end up getting the correct terms in there, that will be fine. So let's have a go at foiling. Using our FOIL, it says expand these algebraic expressions. So here in A, 2x plus y times 3x plus 2y. So that's a binomial product. Let's go. First is 2x times 3x will be 6x squared. First, outside, I guess, is the next thing here. 2x times 2y is 4xy. Plus inside. So I've got 3x times y is 3xy. And last, y times 2y. That would be 2y squared. So there's my binomial product. In this case, there are some like terms, so now I'll even go further and collect the like terms. And here I'll have 6x squared plus 7xy plus 2y squared. So on the first line I did FOIL, and on this one I collect like terms. Let's do the same procedure. N plus 6 times 4n plus 1. So first, n times 4n is 4n squared. Outside, n times 1 is n. Inside, 6 times 4n is 24n. And last is 6 times 1. So there's my FOIL. I now have some like terms that I can add up here. And I can have 4n squared plus 25n plus 6. And so what that says is that this number, n plus 6 times 4n plus 1, is the same as this number, 4n squared plus 25n plus 6. And again, you can check that. If you say, I think checking it's too hard, I'm just going to trust I got it right. But you can check it if you so desire.